Hey there, and welcome to 1.5 on graphing linear inequalities. You're going to see that this is a very short lesson today as we get ready for our mid-chapter quiz tomorrow. 1.5 is graphing linear inequalities, so you're going to be able to graph and apply linear inequalities, and you'll see the standard here is to be able to use systems of equations. We're not doing systems yet, but we're getting there. To represent constant constraints arising in real-world situations. So that's the biggest thing we're looking at there, is being able to use real-world situations. We are doing, it's a little bit of systems as we get through some of these examples today. The first part of this, though, will be just on graphing inequalities. All right, so let's look at example 1, graph this inequality. And so we've got one that is in standard form. X minus 2y is less than or equal to 4. So a couple of reminders from Algebra 1 real quick. So remember that when we talk about what type of lines and shadings, a couple things to remember. Remember that these two symbols, first one being less than or equal to, and then the second one being greater than or equal to. So with those two symbols, remember that we're equal to, right? So anything that would be along the line we draw would be a possible solution. And so the line we draw will be a solid line, some type of line where we show that the solutions are included. Remember, if that we just have a less than sign or a greater than, so less than or greater than symbol, then the line will be dashed. Some people say dotted. But I use the term dashed, and so that line is going to have breaks in it. And what that shows is that the points along that line, while that's the equation of the line, those points along it are not in our final solution set. And so as we look at this first graph, I will tell you that your first step should always be to graph the line, okay? Graph the line. If we can't graph the line, then nothing else matters. And so this is in standard form. And so we could convert this over to slope-intercept form, or if you remember, we could also just use the intercepts. And so remember to do that, the x-intercept, right? Remember the x-intercept would be x comma 0, which means I plug in a 0 for y, which means all of this goes away. And we pretend that this is an equal sign here for a second. X is equal to what? 4. So my x-intercept would be at 4, 0 in this case. 4, 0. If now I want to go find that y-intercept, remember that the y-intercept would be 0 comma y. So I'll plug in the 0 for x, which means that that part goes away. I would divide by the negative 2 to get the y by itself. And so y would be equal to negative 2. So I get 0, negative 2 right here. Remember, to draw a line, you only need 2 points. You don't need 4, 5, 6, 10 points. Some people go crazy putting points up there, but you just need 2 to create a line. Now that we have 2 points, we can draw this line. And so if you're using pencil, you can draw the line with a ruler just perfectly straight and then go back and dash if you need to. Obviously on here, I can't do that very easily, but this is less than or equal to, and so that means we fall into this boat of it being equal to, which means our line will be solid. And so just to keep my line nice and straight, I will put more points out to the left and to the right, just to keep my line straight as I can. And that's important either way, if you're just doing equations or even inequalities, to know what points will actually be along that line, because it matters if something's going to be either on, above, or below, especially as we get into the great detail. Now, let's get to shading. So we've graphed the line, and the second part of that direction would be with solid or dashed. The second step is going to be the shading. Now, some of your teachers might have told you shade this way if the sign's a certain direction, or shade that way if it's a different direction. I'm going to give you a method that works 100% of the time. So what I recommend is using one of 2 points, either using the point 0, 0 or one of the 1, 0 or 0, 1, negative 1, 0, something in that ballpark. Because remember, anytime you can plug in a 0, anything times 0 is 0. Anything added to 0 is itself. And so if I plug in 0, 0 here to my original function, I'm going to come back and I'm going to erase all this now. And I'm going to plug in 0, 0, 0, 0, right? Well, that makes that entire left-hand side equal to 0. So I get that 0 is less than or equal to 4. Is that a true or a false statement? Well, 0 is less than 4, so this would be true. And so my shading will go towards where 0, 0 is. And in this case, that would put my shading going above my line, which may be counterintuitive to some of you because you're looking at that inequality, as I shade this through, you're looking at the inequality and saying, but wait, it says less than. And that's right. In standard form, that sign can play tricks on you. It's not always going to go in the direction that that sign will tell you. Okay, so that's example 1 there. This problem is done. We've graphed the line with the appropriate solid or dashed, which it was solid in this case, and we've shaded our region. And it doesn't have to be perfect. I know some OCD people in my class are going to probably shout that, hey, you didn't get it all the way touching the line. Y'all will be fine. All right, so number 2, and I forgot to put a graph in here. And like magic, there's a graph. So now we're going to take 2x plus 5y is greater than 10 and graph it on this coordinate plane. Again, I said that one of the ways that you could do this is solve it into slope-intercept form. And so just to show that method, if I take my function, and I take 2x plus 5y is greater than 10, I could subtract the 2x, cancel that out, get 5y is greater than negative 2x plus the 10. We're going to divide both sides by the 5. And so we get that y is greater than negative 2/5 x plus 2. So again, if you want to go to slope-intercept form and graph out of that form, that's fine. So if we're doing this, we would start at positive 2. Our slope is taking us down 2 and right 5. And look what it gives us anyways. It gives the x and y intercepts. Now, had we gone to find those x and y intercepts going back to standard form, we would be 2 times the x plus 5 times 0 is equal to 10, so 2x is equal to 10, so x is equal to 5. Hey, look, the x-intercept is 5. And 2 times 0 plus 5 times y is equal to 10. That cancels. So 5y is equal to 10, so we divide both sides by 5 and get y is equal to 2. So y-intercept of 2. So we see we get the same line either way. Now let's talk about shadings and lines. So in this case, my line, if we come back to our inequality in either the standard form or the slope-intercept form, it doesn't have that equal bar. So if it doesn't have the equal bar, then what type of line is it? It's dashed. And so I'm just going to continue my line down using the same slope that we found before so I can make a nice pretty line. And again, it's important to have your line as straight as possible as we draw this. And so coming through like so. Now, let's look at our shading. Again, go back and pick a nice, pretty point that you can test. And again, if your line doesn't go through the origin, you choose the origin. Because when I plug in 0 here and 0 here, is 0 greater than 10? 0 is not greater than 10, so the origin is not a solution this time. Now, if you want to test a point on the other side, and so we could, for example, test 0, 4. And so when we plug in that 4 in for y, again, we're going to have 0 for the x, so is 20 greater than 10? It does check out. And so in this case, my shading does end up above the line. So all of this. And it's important to shade wherever is technically above the line, because any of these points in this shaded region are a solution to that inequality. Okay, and so talking about points that are solutions or are not solutions. So for example, let's just look at a couple points here. 0, 4 is a solution because it's in the shaded region. But let's go back to our y-intercept for a second. 0, 2. Is that a solution? If I plug it into 2x plus 5y is greater than 10, Well, I'm going to have 2 times 0 plus 5 times 2 is greater than 10. That cancels. So 10 is greater than 10. Is 10 greater than 10? Nope. So that's not true. So the ordered pair of 0, 2 is not a solution to this inequality. All right, so we've done a couple graphs. Now we're going to look at some word problems here as we go through. And so the first example here, we have one tutoring company advertises that it specializes in helping students who have a combined SAT verbal and math score of 900 or less. Keep it important there, 900 or less. Write an inequality to describe the combined scores of the students who are in prospective tutoring clients, and let X be the verbal and Y be the math. Now, we could have done V for verbal, M for math. You don't always have to use X and Y, but this one did define us in that direction. And then it says to graph the inequality, and so we're going to do that afterwards. And I'll show you how we can do that in Desmos to get those graphs a little bit quicker, but I'll also show you how to do it by hand. All right, so understanding this inequality, right? So understand that SAT is 2 parts, verbal and math. And so those 2 scores add up to your combined SAT score. And remember that the max score in the SAT is 1600. But this says that this company will tutor you if you have a 900 or less. And so the 900 is going to go over on the other side. The question becomes, what inequality is going to go here? Well, think about what value has to be, in this case, smaller. Is the combination of math and verbal going to be smaller than the 900, or is the combination going to be larger than the 900? Well, it told us 900 or less, so it's going to be less. But now here's the key. Can it be equal to? And so yes, it can, because it said a score of 900 or less. And so here's my inequality. I've written the inequality. Check on that. Now, it says to graph it. And so if we go to the coordinate plane and we just sketch a little graph here, and I'll tell you that for your work today, I'm going to give you sheets for it. And so you don't have to worry about redrawing all these graphs. It'll be already printed out with the coordinate plane for you. But if we had to draw this out on our own, understand what our x and y intercepts would be. Well, our x-intercept would be 900 because 0 for y, and our y-intercept would also be 900. Now, so intercept means I can just draw my line in between those 2 points. And again, drawing as straight as I can. And if I'm going to test which point that I can use to see if it's going to be above or below, I go back to the origin. And if I go to that origin, 0, 0 is 0 plus 0 less than 900, absolutely. So all of my shading is going to be in this triangular region here. Oops, don't want to do that. One more time, there we go. Don't want to lose the graph. So all my shading is down below my line. And so anything in that shaded region would be a point, and that's what we're going to get to in question B in a second, of where if I have a score here, they'll take me, right? So I could have, like, you know, let's say this is a 500, X is the verbal, and let's say a 300 on the math. That only adds to 800, right? Now, obviously, there's some restrictions here. Each section of the SAT and ACT are restricted to 800 points. And so we'd actually have some additional lines in here that this graph would actually stop here at 800. It wouldn't go out. And same thing here, it would stop here. For this function today, we're not going to talk about that too much. We'll talk about systems tomorrow in 1.6. Okay. So question B does say, does a student with a score of 480 and 410, verbal and math respectively, fit the tutoring company's guidelines? And so we could graph this and find it, right? Or we could plug into our inequality. And so 480 plus 410, is that less than or equal to 900? Well, 480 and 410 is 890. And so it does check out that it is less than or equal to the 900. So does it comply? Yes, it complies. So that student would be eligible for tutoring at this company. All right, so I've gone to Desmos and I've drawn a couple of these graphs. And so you'll see the first graph is mirrored to what I've got here. You'll see that it goes from 900 to 900 with that line in between, solid there, shading all the way. And so again, if we forget about what the SAT actually scores their test at, that would be a normal graph. I just want to show you, for those who are thinking about it, remember the SAT scores, the minimum you get on a section is 200, the max is 800. And so you'll see what this actually does to this graph in the end and what scores would actually be valid in the end. Because again, you can't go under 200 on a math or verbal. And so that actually restricts us to only a 700 on the verbal side and not the full 800, because again, you can't get below 800 on, or below 200 on either side. Okay. All right, last example here. 2 math classes are going on a field trip. The teachers have requested volunteers to go on the trip as chaperones. However, there's only enough seating for 55 people on the bus. And so which inequality would describe the number of students and chaperones that can ride on the bus? And so obviously we've got just the numbers of students and chaperones, and that's the C and S that are available in all 4 of these options here, right? So that part's not changing in our 4 options. And the 55 doesn't change, right? So all that's consistent in our 4 options. The question is, which inequality can we have? And so think about the seats on the bus. Can I put more than 55 people on the bus or less than 55 people on that bus? And so I can't put 56, right? Because that would be above capacity. And so it's got to be less than, right? The number of people that go on that bus have to be less than the number of people that are possible. Can I put 55 people on that bus? It says there's enough seating for 55. And so yes, I can be equal to. And so the correct option would be B. And so again, we could graph up this if it asks us to. 55 for the x-axis, 55 for the y-axis, because this will be C. Or actually, we'll do S first because students are more important. Chaperones, not to say that my chaperones on trips are not important, but we would get this as our line. And it would be solid again because we could be equal to. Can I have less or more? It's less. Could I put 0, 0 on a bus? Technically. And so my shading would be all down here. And so question B, or question D actually, continuing with this example here, is going to ask us, can I fit 10 chaperones and 47 students on this bus? So let's go to that equation. S plus C is less than or equal to 55. So I've got 47 students and 10 chaperones. Is that less than 55? I get 57 is less than 55. That is not true. So no, I cannot take 10 chaperones and 47 students on the bus. And remember, word problems should have word answers to them. Relate them back to the initial problem, right? So I don't think we did that with, no, we said yes, it complies back in that example. But no, I cannot take 10 chaperones and 47 students on this bus because I'd be over capacity. All right, that is 1.5. Again, a little longer than I want to make it, but I hope you got as much as you need out of it. Your assignment is there for you. And don't forget, we are also reviewing today for the mid-chapter quiz tomorrow. Good luck.